All right, welcome everybody, and thank you for tuning in and listening to my presentation. I'm not going to present a whole lot of heavy-duty stuff. I wanted to give you some idea of what we can do in terms of diversifying and perhaps reducing the risk that you may encounter when you are producing crops. I'm an extension specialist at the university, and my background is in agricultural engineering. And so I'm viewing this topic and this talk from an engineering perspective. And I do know a little bit about growing plants, but I'm not an expert in growing plants. So I want you to keep that in mind when we go through the presentation. So the second slide that I'm showing here is showing you the progression of the agricultural systems that we have used and are still using for growing crops. So we start with field production on the left-hand side, which is considered a low-tech approach typically, although we can certainly bring in advanced equipment to seed and process and harvest our crop. And then we move up to, from a controlled environment perspective, to more advanced structures. After the field production, we can put some plastic over crops. We call those high or low tunnels, depending on the design. We can also install simple greenhouses or hoop houses. And then as you go down the list, going to the right, you can see we advance to more sophisticated greenhouses, eventually going to indoor and vertical farming, as well as eventually to autonomous farming. We're not quite there yet, but they have examples already of systems that are able to produce crops almost autonomously, where perhaps a manager or a farmer has some oversight remotely, but mostly the crop production is done autonomously in an off-site facility. And the pictures are showing you some of those examples of the various systems that I just described. So what I plan on doing today is to go through several of these production systems and highlight a little bit about how they work and what's specific about them. And also I identify some of the risks, or I call them challenges, related to these systems. And again, I'd like you to think about this as opportunities for you to perhaps include and incorporate some of these production systems in your own operations, in the hope that combined with all the other things you do, you will have a reduced risk for various circumstances that may come up, some of which were described by Melissa earlier. So the first system I want to talk about is field production, but field production with a slight modification in an attempt to reduce the risk of adverse weather conditions. And here you see an example of row covers being installed over field crops in an attempt to try to protect the crop a little bit better from outside weather conditions. So you still grow your crop outside, but you try to cover it when necessary to reduce perhaps some adverse effects of the weather conditions. The challenges are with this system, and perhaps you can call them risk, I call them challenges, is that it's labor intensive. You need to pay attention to the weather, and you need to pull the cover when you think it needs it, and you need to remove it when it doesn't need it anymore, because obviously the cover will have an impact on, for example, light availability to the crop. So you want to manage this, and that typically means you have to have the manpower to install these systems and to manage them properly. And of course, these systems clearly provide limited protection. So it's not a put it on and forget about it, and you're guaranteed that this will protect your crop. No, that's not the case. You are able to provide some protection, but if the weather conditions are adverse enough, you still will have damage to your crop. So next, I wanted to show you an example of low tunnels. The picture that you're looking at was for a research site, and therefore the tunnels are kind of short and small. You have to envision in a commercial setting, these tunnels will span the entire length of the row. But in this was for a research project, so they were small separate trials under each of the small tunnels you see here. But the idea is the same. We basically plant crops in rows, typically with some kind of a mulch, in this case plastic mulches, and then we can put a plastic layer over it, a transparent plastic layer, and you see it's a pretty simple installation with metal hoops and then some bungee cord to make sure that the plastic is kept tight to the support frame, and that support frame of course keeps the plastic away from the crop, so the crop is not hindered at all by the plastic that we put over it. And again, we put this plastic over the crop when necessary. In this case, you're looking at the plastic mostly removed because the weather conditions are favorable. But when the weather conditions are not, then we typically pull the plastic all the way over the plants to try to protect them. And we call these low tunnels because they are too low for a person to really work inside in. In other words, you can't walk inside of them. And that's where the name comes from. The challenges are, as before, it's quite labor intensive. You have to keep an eye on the weather, and you have to keep an eye on how your plants are doing and what the plants are experiencing. And then based on all that information, you make a decision whether you need to keep the plastic over the crop or whether you need to pull it up, as you see in this image, to try to expose the plants more to the outside conditions. And of course, eventually that plastic will become a waste material. These plastics typically don't last terribly long, maybe a season, maybe 2 seasons, but after that, they start to become brittle and they have to be replaced. And if you have a large field with lots of these tunnels, then you're going to generate quite a bit of waste in the form of discarded plastic. And that, of course, is something you have to consider when you are trying to have an environmentally friendly production system. Similarly, you can start considering growing your crops or perhaps your seedlings in a system like this. We call them cold frames, protected structures that are relatively inexpensive, low to the ground, basically glass frames that can be opened up or closed depending on the outside conditions. And when they're closed, they hopefully protect the crop from some colder temperatures or windy conditions or rainy conditions, so that the crop has a better chance to start developing before you would be able to develop that crop out in the regular field where it's unprotected from the weather conditions. Some of these can be heated. You could imagine putting some heating pipes in the ground before you plant the crop and provide a little bit of heat. And so these can become sophisticated depending how far you want to go with the technology involved. But typically, they're pretty simple and they are operated as you see here. In this case, they're closed in the image, but as the weather gets better, then typically the windows are opened. They use sticks to keep them opened during that period of time to support the frames, and the plants will then be exposed to mostly the outside conditions. Again, these systems are labor intensive. You need to make sure you keep an eye on the weather, and you need to make sure that the plants is exposed to the best conditions to give it the best chance to develop properly. And a challenge is that you have to be careful because these are typically designed with glass, although you could design them with plastic materials, either a plastic film or a rigid plastic panel. But glass has typically the highest light transmission, so that's often why people pick that material. But the glass can break, either because of an accident or because of a hailstorm coming through. And if the glass breaks, of course, that will have an impact on your crop. Moving up to the next level of sophistication, here we're looking at a high tunnel. So it's the same idea as a low tunnel. You put a plastic cover over the crop to protect it and to make sure it gets the best conditions possible to develop. And in this case, these tunnels are tall enough for us to walk in and tall enough for us to drive small farming equipment through them so that we can more easily work the soil and prepare the beds and perhaps even harvest the crop, depending on what kind of equipment we want to use. So here you're looking at a high tunnel in which they grow leafy greens, in this case lettuce, right in the soil. It's a relatively inexpensive production system. You do need, of course, to build the structure, but after that, it's very much like growing in a regular field. So there's a relatively minor investment necessary to produce your crop after you've built the tunnel. And as you can see, they use sprinkler irrigation system to irrigate the crop as necessary. You can also see, if you look further down towards the end of the tunnel, that the air looks a little hazy. And that's because the humidity in the tunnel, when I took this picture, was quite high. And that indicates that it's quite challenging when the conditions are cold outside, when you do not want to ventilate, to maintain the right humidity conditions. And so this is a challenge that we have. We have limited opportunity to regulate the environment in these tunnels. And in some circumstances, we may have conditions that are not so suitable for growing your crop or may in fact harm your crop. So providing adequate ventilation becomes a challenge. We do have nice protection, but clearly when the sun comes out and provides a large heat load in the structure that we need to get rid of, because otherwise the plants get too hot, having adequate ventilation can be a challenge. Here's another example of a high tunnel, a freestanding high tunnel. And I want to point out, in this case, we use roll-up sides. Both the left and the right-hand side of the tunnel are equipped with roll-up mechanisms, a pipe on which we roll up the plastic film to allow for a large opening area to allow for ventilation going across the tunnel. You also see in this image that these tomato plants are no longer grown in the soil, but they're actually grown in soil media bags. And that is because if you grow crops in these tunnels over time in the same location, you run the risk of getting soil-borne diseases. And this grower opted to try to stay away from that issue by growing this tomato crop in bags. So the bags were laid flat on a landscape fabric, and the landscape fabric was placed on the soil inside the tunnel. So the landscape fabric does two things. It prevents weeds from growing and causing issues, and it also makes it a lot more convenient to walk on the soil during manual labor activities within the tunnel. And so you see then they placed the bags on the landscape fabric, and then they made small openings in the bags, and they pulled a drip tape through it from the front to the back, and that's how they irrigated the crop. And then they hammered stakes through the bags to string wire to have support for the plants as they grow bigger, because tomato plants, as you know, carry quite a bit of weight when they are loaded with fruit. And so you need to support those plants, otherwise they will tip over, and it becomes a difficult challenge to manage that crop. So a challenge with this system is, again, that it is labor intensive, both from the management point of view, when you start opening and closing the sidewalls because you want to maintain a particular type of temperature. There's a range of temperatures in the greenhouse or in the high tunnel. You need to constantly keep an eye out for the weather and make adjustments accordingly. So that can be labor intensive. And of course, when you grow a crop like this, it is quite labor intensive too. You need to start the plant material, you need to stake them, you need to string them up, then you need to harvest. So quite a bit of manpower goes into a system like this, and you have to have that manpower available. So that's the challenges associated with the tunnel, the labor in the intensive part of the production system, as well as providing adequate ventilation to make sure your crop doesn't get too warm when the sun is out. We also have growers that use larger areas with tunnels to grow their crops. Here you're looking at a raspberry crop in what we call a connected tunnel system. So the tunnels are connected at, when you think about the greenhouse terminology, where the gutter would be between the sections, but we don't use gutters between high tunnel sections. So it's a little misleading to call it a gutter connected tunnel system, although that is a term that is sometimes used by the industry or in the industry. But it's really tunnels that are placed close together, and it's at the sides, their roof covers meet, to cover a larger area to grow a larger number of plants. So in this case, the plants are grown in pots that are directly placed on the soil, and then they use a drip irrigation system to provide the water and nutrients as needed. And so that's a very convenient system, but clearly you have to have that larger tunnel structure installed. And you can see here a little bit how that is done. We use posts to put the to support the structure, and then we use bows, metal pipes that are bent in bows to span the width between the posts, and then we put a layer of plastic film over the bows, and we use cords or bungee cords or rope to keep that plastic then in place during the production. This picture was taken in August, so later in the growing season when the end walls were no longer needed, and so they were removed. But if you overwinter or you grow earlier in the season, later in the season, then you typically install end walls. So there will be plastic end walls then to protect the crop. Overwintering in these structures is challenging, and that's mostly because we are concerned about the snow load. These structures are not very strong, as you can see by the size of the post. And so if there was a significant snowfall at this site, it would likely collapse the structure. So these gutter connected or regularly connected tunnels, high tunnels, are typically not designed for winter production. The earlier high tunnels that I showed you, the freestanding, are typically designed a little sturdier, and they can be used for winter production. Of course, you need to have a cold hardy crop for that situation. All right, moving on to the next tunnel, and that's a tunnel in an urban setting. And so in this case, the challenges are finding the right location. Where can you place a tunnel in an urban setting? What is the soil like at that location, not only for construction, but clearly also for production? You don't want to grow your crops in contaminated soil, and that's why you see in this particular tunnel, benches were installed. So in this case, the crop was not grown directly in the soil because it was contaminated, and the crop will be grown on benches, so in pots or in other materials, to make sure that there's no connection, no contact between the media in which we grow the crop versus the soil that is covered by the tunnel. You can also see, because this was a small site, so it was never the intention for equipment to drive through to till the soil and prepare the beds for plant production, they decided to install more fancier, more sophisticated end walls. In this case, they used rigid plastic panels and a nice aluminum door to access the facility. In commercial systems out in the field, you probably wouldn't see that because that would be considered too expensive of a design for a high tunnel. But in this particular application, in an urban setting where the purpose and the use of the tunnel is slightly different, you can see greenhouse-like features on a high tunnel. Moving on to the next tunnel, and this goes back to the issue that I mentioned earlier, where we can get contamination of the soil if we grow year after year or season after season in the same location. Some growers have decided to install these movable tunnels. And if you look closely, you see a pipe laying on the ground in the foreground and also in the background. That's a pipe that is used as a rail. And then the tunnel that is visible in the background can slide back and forth on that rail to different locations. And so this allows the grower to manage a particular site by doing something very similar as what growers of farmers often do, which is called crop rotation. So you can grow your crop in a specific area for one season and then decide to move your tunnel to another area, an adjacent area, where you grow your next crop, and then you can remediate or let your soil recover, for example, by planting a cover crop in the area where you previously grew and where the tunnel was located. One of the challenges with this system is that we have to be concerned about wind protection. these tunnels need to be anchored into the ground, otherwise a strong wind will likely do some damage or maybe even lift them up entirely. And so the short metal posts you see in the foreground and in the background are used to anchor the tunnel to once it's moved to that piece of property that is closer to us in this image than where the tunnel is sitting right now. So you have to worry about that, because typically, of course, in a fixed location tunnel, the post will go some distance into the ground, typically 3 or 4 feet, and that will be enough anchoring to hold that post in the ground during high wind conditions. But once you put your tunnel on a movable track, then you need to think about anchoring that tunnel structure to the ground carefully to avoid any damage from wind conditions. Then moving up to greenhouse production, and this is a more advanced production system, and it also means typically a more expensive production system. And so while I'm showing you a pretty large greenhouse operation that probably is a very expensive system to build and to start with, I'm not trying to convince you that that's what you have to do. What I'm trying to show you is that you can use some of the ideas that people use in greenhouses to start on a smaller scale and build out from there. So here we're looking at a greenhouse in which they're growing lettuce plants. This is a European greenhouse where they grow a curly type lettuce, and they typically grow heavier lettuce heads in Europe than they do in North America. So that's why these plants look quite big. And they're grown in what we call a nutrient film technique system, or an hydroponic system. These are plants grown in gutters or in troughs that are placed on a small slope. At the high end of the trough, water and nutrients will be introduced, and then by gravity, a small water volume will continuously flow from the high end to the low end of the trough, where the excess water and nutrients are collected, treated, and then reused for the next irrigation cycle. So in these systems, we can grow year-round. That's what they are designed for. And so that's a significant advantage. We don't have to worry too much anymore about cold conditions, because we have heating in the greenhouses, we have cooling, and we can maintain pretty much an optimum environment year-round in these facilities. You also see some supplemental lighting fixtures overhead, so that means that when it gets dark during the winter months, they can also turn the lights on and make sure that the plants are receiving enough light. Now the challenges are, obviously it's much more expensive, and any interruption in the supply of water and nutrients can quickly become an issue. There's not a lot of water around the roots at any particular point in time, so any interruption in that water flow, for example, when a pump fails or the power goes down, will quickly result in damage to your crop. So that's something you have to design for and include redundancies for in your system. We don't have to do it horizontally, we can also do it vertically. Here you see the same idea. We pump water to the top of these channels, the high end of the channels, and then by gravity the water flows down. And in these channels we have little openings where we can put individual plants, as you see in this image, and we can grow in that particular system. And then the base of the system is the container in which we collect all the excess water, and we pump it back up again to the top of the channels and let that system continue. The challenge is, in this case, how can we distribute light evenly from the top to the bottom? You can probably already envision that the plants sitting at the top of the channel are likely to receive more light than the plants sitting at the base of these channels. And that may result in uneven growth of the system, and therefore we have to either add additional lighting at the bottom, or we have to design a production system that can accommodate for the fact that there are different growth rates in different locations in this system. So the management could become a little bit more challenging. We can move away from having a small amount of water by the plants by growing plants, as you see in this image, in what we call a deep flow system or a pond system, where plants are grown in styrofoam floaters that float on maybe 8 to 12 inches of a nutrient solution. So in that case, if there was ever a pump failure, it would not be an immediate concern because there would be plenty of water available for the crop for many hours before the situation became critical. It makes it very easy to move plants through your production system because they're all floating on water, and it doesn't require a lot of force to push plants from one side of the greenhouse to the other side. However, there is a challenge, and that is the fact that roots require a little bit of oxygen for their respiration, for the process that they use to survive. And because we close the top of the water off with layers of styrofoam boards, there is a lot less diffusion of oxygen into the water. And that means that if you don't add additional oxygen to this nutrient solution, you may run the risk of the plants not having enough oxygen available to their roots, and that may impact the production of the plants. Another example of crops we can grow in greenhouses is shown in this image. These are strawberries, obviously. Note that the strawberries are hanging from the frame, and that's done so that we can adjust the height so that it's easier for the workers to reach the berries. Imagine if you had a greenhouse full of strawberries and you had to crawl on your knees to pick the berries all day long. That would be a very challenging task. Now you can, as you see in this image, you can stand behind a cart that is running on tracks. Then the tracks are also the heating pipes for the greenhouse. So it's a combination of functions that these pipes provide. But it's very convenient for the workers because the berries are at a convenient height, and they can easily select which berries they want to pick as they move along. We typically use bumblebees for pollination because bumblebees are much more effective and much more precise in the pollination of the flowers, and that typically results in much better formed berries and much higher yields of the crop. And that's a very common and a very well-developed system that growers of strawberries, but also of tomatoes or cucumbers or peppers are typically using. The challenge is that it's still a labor-intensive crop. You can imagine you have to go through this crop regularly to make sure you pick the right berries. And so you need to have a fairly large labor force to make a system like this work. And the other thing I wanted to point out, because this image was provided to me by a lighting company, you can see some lights hanging over this crop in the center of the image. Those lights are not for supplemental lighting, but those lights are low-intensity lamps that provide the signal for the plants to start flowering. What we're doing with those lights, we are manipulating the day length or the signal that the plant is using for them to perceive the day length. And by extending the day length, we can induce this particular cultivar to start flowering and produce berries. So we use that light as a triggering mechanism for the plants to start producing. Here's a greenhouse filled with tomatoes. Again, we have the heating pipes in the center that we use to drive carts on, but are also used for heating purposes. We call this the lean and lower system. So these plants are typically residing in the greenhouse for 10 to 12 months. And during that period of time, the stem of each individual plant can reach 30 to 40 feet. And so the greenhouse is not that tall, obviously. What we need to do is we need to move the plants further down the row, if you will, in order to support the production. So here, that's why you see a bunch of stems coming out of the rooting media and typically running horizontally for a while before the last part of the stem is going vertically up, and that's where you see the fruits being produced. So it is a reason or it is a method that we can use to try to produce these otherwise very tall plants in a structure of limited height. You can also see that in this greenhouse, they're using LED lighting. The purplish color that you see is produced by LED lamps that are placed, in this case, in between the rows of plants to try to make sure that most of that light that's expensive, of course, to deliver is getting to the plants and is used by the plants to produce the fruits. And then the person in this image that is fully covered in or fully clothed in a protective suit, that's because this was a research project, and I was a visitor when I took this image, and they didn't want any contamination at that particular site, and so you could only visit if you agree to completely cover yourself, your hair, and your clothing and your shoes, to make sure that there was no opportunity for any contamination as outside visitors came into the facility. So the challenges with this system is that it's still labor intensive to harvest, and you have to handle the fruit properly because you want to make sure you don't bruise, you don't reduce the quality, the appearance, but you also don't want to damage or hinder the flavor and things like that. So you have to understand what you're doing and make sure that you follow the correct procedures. And then, of course, as I alluded to with the protective clothing, you want to be very keen on managing pests and diseases, because this is a high density crop, and any pests and diseases that come in and find a very nice environment typically spread very rapidly and can cause significant damage. I also wanted to have a few slides to talk about crops other than edible crops. So here you're looking at a greenhouse with bedding plants and hanging baskets, indicating that we can grow in multiple layers. And of course, growing in multiple layers adds to the space efficiency. We can grow more crops, more units in a particular space. And especially in a greenhouse where you know that the space and the maintenance of that space is expensive, it typically pays off to try to grow in multiple layers. And so sometimes, as in this picture, you see 2 layers, hanging baskets and benches underneath. But in some greenhouses, they grow in 3 layers. They also grow a crop on the floor underneath the benches that you see here. And then during the daytime, when the weather is suitable, they will slide out that bench layer so that the layer of crop on the floor also gets enough light to grow and to develop properly. The challenge is that, of course, when you have multiple layers, then the top layers can take light away from the bottom layers. And so you need to manage that properly to make sure that all the crops that you're trying to grow get the right conditions and grow at the rate that you're expecting. And then, as you can already see in this image, there are a variety of different plant species in the same space. And that means that you typically have to compromise in terms of your environmental control to make sure that most of the crops will find some set of conditions that they can live with, although it may not be optimum for all the crops. And so you may see some crops grow less quickly as a result of the fact that the conditions are not quite optimal. Some of the crops we grow are very high value. Here you see an orchid greenhouse. So it's a very specific crop for a very specific market and the crop needs specific conditions. The challenges are that it's a fairly labor-intensive crop again. You need to make sure that these flower spikes are properly staked and properly guided to give the appearance that the customers are looking for. And because this is a very expensive crop, any mistakes the grower makes during the production can quickly become a very major financial hit if that reduces the quality or reduces the yield of this crop. So you really need to know what you're doing and follow the correct decision scheme to make sure you get the quality and the product that you want out of this system. And then I wanted to, in the end of my presentation, talk a little bit about some more of the high-end facilities. Here you see a rooftop greenhouse installed on top of a Whole Foods market, so a supermarket in Brooklyn, New York. And of course, that system considerably reduces the amount of transportation needed between where the crop is produced and where the crop is sold. All they have to do is harvest in the greenhouse and then move the crop downstairs, package it up and put it on the shelves for customers to buy. So that's a major advantage of a system like this. But clearly the challenges are you need to design, in this case, your supermarket, so it can support a greenhouse on top of it, and that the greenhouse does not cause any issues, for example, with leaks in your supermarket down below, because obviously that would not be a good situation either. This, by the way, the stream you see in this image is the Gowanus Canal, which was a highly polluted water stream in New York City and Brooklyn in this case. And you can see they've worked very hard on trying to improve conditions, and now it looks much better than it used to be. This is a greenhouse that is designed and operated by Gotham Greens. I'll give you the link on the bottom here. Also a link for the Whole Foods market, and then the third link is the photographer who took the image. This is a pretty advanced supermarket. You can also see they have solar panels on their parking spaces, and if you look very closely, you see some windmills surrounding the parking lot as well. So they really went all out trying to showcase sustainability and using a greenhouse to demonstrate the fact that yes, it is possible to really reduce the food miles that most of our food travels, and of course contributes to fossil fuel consumption and as a result global warming. We can also grow in shipping containers. Here you see a shipping container designed and sold by freight farms. And of course, the advantage of those systems is we can put them anywhere. So freight farms designs them. You can basically buy them as turnkey systems. They are in the neighborhood of $100,000 to $150,000 a piece, but fully outfitted, fully equipped. All you need to do is provide electricity and water supply, and off you go. Everything else is already in the system, ready for you to use. And we can put those down anywhere we want to. It could be, in this case, in an abandoned parking garage or any other location that you can imagine. But the challenge, obviously, are you have a high initial investment and you have limited space. A shipping container is 8 feet wide by 8 feet tall and maybe 40 feet long. And that's the space you have. And of course, you can buy more shipping containers, but that's going to add more cost to your operation. But it's an interesting approach, and I think for certain situations, certainly something to consider. And then another indoor farming example is aerofarms in Newark, New Jersey. And here you have a quick view of some of their production facilities. You see it's in vertical layers in shelves. I believe they have between 11 and 14 layers in each of these shelving units, and then many shelving units right next to each other. It is so tall that they need scissor lifts, as you can see in the foreground, to reach the different locations to tend to their crops. And that in itself, I think, is a risk because that's a safety concern. You see the worker being sitting on top of the scissor lift, having a safety harness on and being tethered to the lift in order to prevent falling out of the lift and causing harm. But this is a system that is obviously designed to maximize productivity per unit volume or per unit floor space, and a demonstration of the fact that you can do this. You can really maximize production in this case in an abandoned factory building in Newark, New Jersey. But clearly, this is sort of at the very high end of the investment necessary to design a growing system. And so, you need to have the capital, you need to have the backing to pull this off. And as an individual farmer, this is probably something that you can't do by yourself. You need to have investors that help you design and operate a system like this. And then finally, I wanted to recommend some references. Elliot Coleman wrote a very interesting book some years ago that he called 4-Season Harvest, that looked at growing year-round in high tunnels. And I think you will find a lot of good tips and suggestions about the crop selection and the management that you need to do in these systems. I was involved in various research projects that also developed some publications, one on raspberry and blackberry production that you see as a second image here. I, in a previous life, worked as a graduate student at Cornell University, where we were growing lots of lettuce in a greenhouse, and we developed a hydroponic lettuce handbook from that work that you can download and find. And then I also contributed to a book on lighting crops, using supplemental lighting to help us speed up crop production during the darker winter months. And that book is shown on the very right-hand side. And then my very last slide with some concluding remarks are, I hope that you saw and maybe it got reinforced that there are a variety of growing systems available. You don't have to pick one. You can probably do a few of them, and you can sort of jump through the various iterations and complexities and challenges with these systems. The initial investments do not have to be high, although clearly for some of these systems they can be very high. But we also have low-cost growing systems that you can certainly try and you can get very successful with. I always advocate for starting small before expanding. Try it out first on a small area or with a small system before you go in full blast and make a big system. And when you start with something, always try to think ahead and try to think about where you may want to expand or where you may want to build out so that you allow space for that, because otherwise it makes it much more challenging to do those expansions later on. Always develop a market, so know where your produce is going to go or your product is going to go before you make these major investments, because you can be the best grower and grow the best quality product, but if you can't market it, then you're not going to be in business very long. So you have to have a market. Plan for the unexpected. People often think, especially people who know little about agriculture, that this is easy. This is very challenging, despite the fact that some crops appear to be easy to grow. You will make mistakes, you will have breakdowns, you will encounter diseases and pests. And so you want to plan for that. You want to be ready for that. You want to have accounted for that when you make your financial statements. And consider adding controlled environment crop production to diversify your business. Again, I think this goes to the risk and the focus of this NIFA project course. Diversifying your risk is, I think, a good idea. And so adding a controlled environment crop production component to your business may be a good strategy to reduce your risk. So you have something available, for example, when the field production is no longer able to produce a crop for your customers. And consider growing specialty crops to set your business apart. You know, you could still grow tomatoes like anybody else, but if you were able to specialize in a particular product, a specialty crop, you set yourself apart, and that may be a good strategy to be successful in your business. And then last but not least, as I tried to allude to, this is not easy to do. This requires expertise, and that's something that you will have to acquire, or if you can, it may not be a bad idea to hire an experienced grower that can do that for you while you manage the rest of your business. And I'll stop there. Thank you very much for your attention.
Thank you, AJ. Hey, do we have any questions for AJ? A little quiet this evening, but I have to say AJ is a great resource for you. I know in our county we built a greenhouse, and he was awesome coming out and working with our county engineer, and we ended up with a beautiful greenhouse. So be sure to reach out to AJ if you're considering building a greenhouse.
Yeah, I'd be more than happy to talk to anybody who wants to do something with greenhouses or high tunnels. I'm available here, so consider me a resource. And if you're planning on doing something like that, then certainly reach out to me.
Okay. Yeah, thanks for joining us this evening.
You're very welcome.
Yeah. Okay. Oh, we had one question from Meg. Do you have any good resources for polycarbonate greenhouses?
Yes, send me an email and I'll be happy to share information about that, suppliers, as well as some characteristics you want to look for and you want to consider when you think about using polycarbonate.